Hi everyone. In yesterday's video, we talked about how to solve linear systems by graphing. Today we're going to use a more algebraic method, so you're not going to have to graph these every time. So we're going to learn a method called substitution. And when I think about substitution, I think about replacing something with something else. And if you think about that, it's going to make, I think, this a lot easier. So to start with, I want to do something that's a problem we've actually seen before. And so if we look at number one, we have a system here. We have two equations. We know 4x plus y is equal to 1, and we know y is equal to 2. So if I were going to use substitution, I would take what I know. I know that y is equal to 2. And I would replace the variable y with the value of 2. So we're going to take this equation, we're going to say 4x plus, but again, instead of y, we're going to put in 2 because we know y is equal to 2, and we have equals 1. So now I just have an equation with x, and we already know how to get x by itself. So we're going to solve by subtracting 2 first. So here I just have 4x. Here I have 1 minus 2 is negative 1. Then I'm going to divide by 4 on both sides. And we get x equals negative 1/4. So now I know x equals negative 1/4. I was already told that y is equal to 2, so then my solution, remember we said solutions of linear systems are ordered pairs, so our solution would be negative 1/4, comma, and then our y value would be that 2 that we were given. Oops, sorry. So this is a pretty straightforward example of substitution. We're used to substituting numbers in for variables. Now, these other two examples we're not going to do right now. We'll save those for later because that actually gets into more of the kind of meat of these problems that we need to learn. So let's go down here. So how do we solve using substitution? Again, we did a basic example here where we were replacing the value with we know for that one variable. So when we're solving, we're going to isolate one variable, if not already done. So what that means when we isolate, it means we get it by itself. So when I look at my system of equations, I'm hoping that one equation has a variable that's already by itself. So for example, if I look here, I can see in this problem here, y equals x minus 4. Y is already isolated. Or by itself. So in this case, we don't have to do any work because we already have one equation where a variable is by itself. So now what we're going to do is we're going to substitute one variable into the other one. Here's what I mean by that. Here we know that y is equal to x minus 4. So when I look at my next equation, instead of putting y here, I'm going to substitute or replace the y with x minus 4. So in step 2, I'm just going to put a number 2 here because this is step 2. We're going to take 4x plus, in this case, y we know is equal to x minus 4. So that gets replaced. And then we have equal to 1. Okay, so now we're going to solve for the one variable. In this case is y. So in step 3, it's x. We're going to solve for x. Before I can solve here, I'm going to need to do a little simplifying. So I see that I have like terms, 4x plus x. Remember, there's really a coefficient of 1 in front of here. So I have 4x plus 1x is going to give me 5x minus 4 is equal to 1. Now I'm going to add 4 on both sides. I get 5x is equal to 5. Divide by 5 on both sides, and x is equal to 1. So now we're done with step 3. We've solved for one variable. Now it says use the value you found in step 3 to solve for the other variable. So here's what we mean. I know that x equals 1, but I still have to solve for y. So here's what I'm going to do. I know my equation, this is step 4, my equation said y equals x minus 4. However, I know that x is equal to 1. So I can substitute 1 into my equation. So I'm going to get y equals, x we said is 1, minus 4. So then I know 1 minus 4 is negative 3. So now we know that the solutions of systems are ordered pairs. So now I know my x value is 1, my y value is negative 3. So now I have what I think is the solution, but remember we always want to go back and check, and I'm going to do my check right under here. Remember, for this to actually be a solution, this ordered pair has to make both of my equations true. So let's check that out. I have y equals x minus 4. So in this case, I get y is negative 3 equals my x value is 1 minus 4. So I get negative 3 is equal to 1 minus 4 is negative 3. So I know that checks out. Now I have to check it in my second equation. 4x plus y is equal to 1. So we're going to do 4 times, in this case my x is 1, plus a negative 3, and that hopefully is equal to 1. So 4 times 1 is 4. I know adding a negative is the same as just subtracting. 4 minus 3 equals 1. And that tells me that my solution checks out. I do have the right answer. So I know there's a lot that goes into this. Let's go ahead and do one more example, and then we'll do some others in class to make sure everyone feels pretty comfortable with this whole process. All right, so let's do number 1 on the next page. So we're using substitution. It says solve the linear system by substituting. And remember, when we see substituting, we're thinking replace. So if we think back to our steps, the first step was to get one variable by itself. And the nice thing here is that's already been done. I have y equals 3x plus 2, so I already have a variable by itself. So I don't need to do any work in that step. Step 2 told us to substitute one variable into the other one. So what that means for us is I know that y equals 3x plus 2. So that is going to replace the y in my second equation. Sorry, I'm moving this all over. So here's what's going to happen. I'm going to take that second equation, x plus 2 times, now I'm going to have to use parentheses here. I know that y is 3x plus 2, and that should equal 11. So now we've got an equation. It just has one variable, x, and we need to solve for x. So the first thing I see here is that I have parentheses. So I need to distribute the 2 to both of these terms. 2 times 3 is going to give me 6x. 2 times 2 gives me a positive 4, and then I have this x. And that should be equal to 11. Now I notice I have like terms. I have x, and I have a plus 6x. Again, this is really 1x, so now 1x plus 6 more x's is 7x, plus 4 is equal to 11. And now we're down to a two-step equation. I'm going to subtract 4 from both sides. I get 7x is equal to 7. And if I divide by 7, I get x is equal to 1. So now my job is to figure out what y is equal to. So I know that y equals 3x plus 2. But I know that x is equal to 1. So now I can do y equals 3 times my value of x is 1. Then I have plus 2. If I simplify that, I get y is equal to 5. So the ordered pair, my solution is always an ordered pair, is going to be x, which is 1, comma, the y value, which is 5. Now again, we're always, for our last step, going to check our answer. So we're going to plug our ordered pair into both equations. So my first one was y equals 3x plus 2. So my y coordinate was 5. I have 5 equals 3 times my x coordinate was 1 plus 2. If I simplify this, I get 3 plus 2 is 5. 5 equals 5, so that checks out. My second equation was x plus 2y equals 11. So again, I'm going to go ahead and substitute. X is 1 plus 2 times the y coordinate was 5. So if I do 2 times 5 is 10 plus 1, I get 11 equals 11, and I know that I have the correct solution. So that is how we substitute. Now there's one more thing that can make this a little tricky, but we'll take a look at that in class tomorrow. So make sure you've got good detailed notes. Go back and review anything that you're not feeling comfortable with, and I will see you tomorrow. Thanks.